So now let's talk about resonance. So what is resonance? Actually there are some structures which are not capable to explain all their properties in a single structure. Okay, there are some compounds which are not able to explain all of their properties in a single compound, in a single structure. Okay, so resonance is there are so many covalent compounds in which a single structure is not capable to explain all of their properties of the compound. So we need more than one structure. Of these structures are known as resonating structure. Okay, so we need more than one structure. Okay, so these structures are known as resonating structure. These structures are known as resonating structure, and that concept is known as resonance. Okay, this is known as resonance. So when they are not able to explain all the properties in a single compound, then we take then there are more than one compound which are able to explain. So these are known as resonance. Okay, so actually it is only based on paper. It is not like the structure is it's combining in a solution. It is a concept which is only based on paper and pen. Okay, only based on paper. Okay, on paper we can explain that why this structure is so stable, why this structure is not stable, with the concept of resonance. In real, electron are moving, but the structure may or may not be moving. Okay, it is a hypothetical phenomena. Again, it is a hypothetical phenomena which explains the extra stability of compound, which explains the extra ability of compound. So it is a hypothetical phenomena. On the paper with the help of pen we use the structure, and we are able to explain why the structure is gaining more stability. That in deep we will be studying in that thermochemistry. Deeply we will be studying in thermochemistry. Now let's come back to resonance. To resonance there must be conjugating structures. There must be conjugating structures. Okay, so what are the conjugation structures? There are several type of conjugation structure. Like first structure, a positive charge is in conjugation with double bond. What does it means? Like carbon has a positive charge. Now there is a single bond. Now carbon has double bond carbon. Okay, so if you complete the valency H, it has H2C, it has CH2 again. Okay, so this is a line represent. Okay, now this is the original compound. So now it is known as conjugating structure. Okay, a charge is in conjugation with double bond. Charge means a positive charge is in conjugation with double bond. Now if we see other conjugating structures, if you see the rest of conjugating structure, the second conjugating structure is a negative charge is in conjugation with double bond. A negative charge is in conjugation with double bond. A positive charge is in conjugation with double bond. Third structure, if we see, a positive charge is in conjugation with triple bond. Fourth conjugation, we see a free radical is in conjugation with double bond. Fifth, if we see, a lone pair is in conjugation with double bond. Sixth conjugation structure we see, a double bond is in conjugation with double bond. Seventh we see, a double bond is in conjugation with triple bond. Eighth we see, a lone pair, and then double bond, and then double bond. So this is also a resonance. If you see the example of last structure, if you see the CO2, if you see the structure CO2, oxygen has two lone pair. Here also oxygen has two lone pair. Now if this lone pair given to this, now if we see the resonance, so this is our conjugating structure. We will learn how to draw resonating structure. So okay, so when it has lone pair, it will give its lone pair, it will also give its lone pair. Now this type of structure we will get. Okay, so this is the example of last one. Okay, so for resonance whole, now if we see, now just see, whenever there is a transfer of electron, okay, in resonance there is a delocalization of pi electrons. In chemical bonding, you will learn what are pi electrons and what are sigma electrons. Okay, pi electrons are electrons which are not taking participate in the resonance, not taking participate in the hybridization, not taking participation in hybridization. And sigma electrons are those electrons which have taken participation in hybridization. So whenever there is a delocalization of electron, the resonance takes place. Now whenever the one pi electron is delocalizing, so the remaining, now if we see carbon has sp3. Now if we have one pi electron, so it will be obviously sp2. Either sp2 or it will be sp. Okay, so if we consider one pi electron pair, so it is a sp2. Now sp2, it is a planar. Now if we take the example of benzene, everywhere there is a resonance. Okay, all are conjugating structure. If we take its canonical structure, resonating structure, this is its resonating structure. So all are sp2 hybridized carbon. All sp2 means the atom must be planar. Okay, for resonance, the atom must be planar, because in sp3 we cannot find a pi electron, but in sp2 we can find at least one pi electron. So when it has at least one pi electron, it is planar. When it is planar, so then resonance may occur. So if resonance is occurring, it must be planar. Okay, now whenever we use the term delocalization of electron, okay, whenever we using term delocalization, that means we are talking about resonance. Okay, it could be electron pair, it could be lone pair, it could be bond pair. Okay, so whenever delocalization of electron there is then we call it resonance. If we take an example, now if we draw some example of resonance, if CH2 positive, now if it is going in the resonance, it is okay. Now how we will draw the resonating structure? When we will try to move an electron in one direction, then all the electron must be moving in the same direction. Okay, so this is a rule of drawing the resonating structure. All the electron must be moving in same direction. Okay, so when we start moving the electron in left side, then all the electrons should be moving left side. Now Now what we could do? Now we see first and second structure are identical. Okay, if we see first and if we name it as a first structure, if we name it as a second structure, first and second are identical structure. Now these are we call or we can their identical structure. Okay, now if we try to draw the resonance hybrid, when we try to draw the resonance hybrid, we draw all the solid structure. Solid structure means we draw all the pi sigma electron first. First we draw all the sigma electron which were stable. Now when now we do pi electron by dotted line. Then electron pi electron by dotted line. Then we'll add. Now if we see delta plus charge was here, partial positive charge here, partial positive charge was here. So here it was 2 partial positive charge. Now we know the value of 2 partial positive charge is 1. Okay, so that's how we draw the. This is called resonance hybrid. This we call resonance hybrid. So this structure is known as resonance hybrid. So all for resonating structure, we first need to draw all the resonating structure. We need to count how many resonating structure we have. Then we need to draw the resonance